Hello and welcome to learn about 3D printing. Today's topic is 3D printing process itself. And if we categorize this, cut it down to pieces, this 3D printing process. So here's the process itself, cut into few steps. First of all, the first thing is the idea. Then comes the 3D modeling of the idea. After that comes the slicing, or making the 3D model into an understandable form for the 3D printer. Then comes the printing process itself. And after that, possible post-processing. And after that, the piece is ready. But after it's ready, it might need a few more iterations. So there's a little arrow going from the ready step back to the 3D modeling, or back to the slicing, or back to the 3D printing process itself, because something might have failed, or in the slicing process we might have put a wrong setting so that we need a more stiffer part, or in the 3D modeling step we might have put a measurement wrong. So it starts from an idea. It might be a decoration, a prototype, utensil, tool, replacement part for something. It might be a business idea. It might be a sale idea to sell a product or make a whole business out of that. So first is to make the idea into a plan. The requirements for the part. Does it need to be durable? Does it need to have a possibility to clean? Will it be ecological? And what are the resources available? What are the methods of technology? And are there any models available for this? Or does it have to be 3D modeled? What are the softwares that can be used for this? How much time do we have? So those are pretty much the things that you need to take into consideration when talking about the idea into a plan and before starting this process, if you want to make it to follow a certain step path. So planning is always a good thing to do. And after the plan phase, or the idea phase, comes the modeling. You can do it with different programs. The 3D modeling can be done with different programs. So there's a lot of the 3D modeling softwares available. Some of the mentioned there, like Tinkercad, SketchUp, Fusion 360, Blender, OpenSCAD, are free to use. There are many other free software to use also, but these are just a few ones. But like Sims, NX, SolidWorks, and Rhinoceros are pay to use software. But Tinkercad is a good software to start your 3D modeling career in. It has a simple design that you basically drag and drop parts to cut or add to the part itself some material. But if you want a more CAD type software, then Fusion 360 is a good choice. And if you want to do organic modeling for like to make characters or stuff like that, then Blender is a good choice for that. Or some kind of a sculpting software. Or you can use different websites that have 3D models available. There's sites that have very detailed CAD files available, like CrapCAD, and then there are sites like Thingiverse, My Minifactory, and Cults 3D that have just the STL files that you can't modify at all, but you can download them and then use them to print. You just have to remember that you will need to comply with the license set for these files, because many of the files shared up on these websites have a CC license, so you can't just download and start printing and selling the items. But they're all available for your own use. So every file that is uploaded has a mention if it's available for use commercially. But these are great sites to look for parts that already exist. So after you have 3D modeled your part, or got it from a website, or someone else has modeled it for you, it's time to go into slicing. So slicing for example, in FDM, they are the driving instructions to the 3D printer on how to create a physical object. Here you can see an bottle-shaped object that is cut into slices. Very, very thick slices, but each of these slices try to be a layer of a material in here. So it first cuts it into a slice and then looks at how the slice is formed. What's the shape of the slice in 2D? And then it starts to calculate how to move the extruder on top of the part to create it out of thin air. So it cuts according to these lines and then looks each one of them separately and checks how it would create the driving path for the 3D printer. After that's done, it will be exported into a G-code file. There are many slicers available, like Prusa Slicer, Preform, Cura, Simplified 3D, 3D Slicer, Slick 3R. Many printing slicers available, and most of them are free to use. Here's setting page, for example, for Cura on the left. There's a setting page. It asks for different things. It asks for layer height. It asks for wall thickness. It asks for the infill density on how much the part will have material. It asks for the speed of the 3D printer. It asks if it has print cooling on, if it has supports on, and stuff like that. And on the right side, after the slicing is done, it tells you how long the print takes. It tells you how many layers it has, and it also tells you how much material was used for this print. So these are very, very detailed information that they give out. So in slicing, you can set how many parts you want to print. You can set the speed of the print. You can set the material. In software, you have to take into consideration. You have to know how much will the part need any support. You will have to know how we will orient the part, so the orientation of the part. You have to decide on the infill of the part. You have to decide on the wall thickness of the part. These are things that you have to set for each part when you start a print, because not every part will have to be durable. Not every part has to be like really much. Not every part has to have much strength and durability. Some can just be to show off how the printer works, and they just need to look good. So after slicing comes the printing. There are some preparations for this. First of all, cleaning the printer, cleaning the build plate, the heated bed where the print will be formed. Again, we're talking about FDM 3D printing or SLA. You have to check the watt, for example, for SLA if there's any failed prints last time. But if you know that there's no failed prints, you can skip the cleaning of the watt. Insert material, check if there's enough material in the printer. Then heat the chamber, for example. If it's very cold, like 10 to 15 degrees, it might not provide very good results. For example, for SLA printing, it needs to be 20 to 25 degrees at least. And same thing, of course, for FDM. It works a bit better when it's around 20 degrees Celsius. Check if the bed is level. You don't have to do that every time, but just to make sure that it's almost there. Usually, most of the 3D printer, FDM 3D printers nowadays have auto bed leveling, so they do it themselves automatically. And in SLS printing method, you have to clean the powder. You have to make sure that there's a mix of fresh and used powder if you want to use used powder. And then moving the file to the printer. You can move it either with USB stick, SD card, or over the network. You can send the file over the network. And first layer or start. In FDM, this is basically where you can see if the print is leveled, if the Z height is adjusted correct, and you can see if the first layer is successful. And usually, like 95% of the cases, if the first layer is successful, then the print will succeed also. And you will see the adhesion of the print in the first layer. And you will see also any material clocking issues on the first layer. If the nozzle is too low, it will start clock the extrusion completely. Or if there's like some leftover material from the last time you printed the material that needs higher temp, you will notice that too. And you will see, of course, your settings if you forgot your supports. But if you miss the first layer, there's always the monitoring aspect. You can monitor your print with different methods, either adding a webcam and webcam feed from that, or many of the printers, some of the printers have an integrated webcam, as you can see on the right. Left is another case that can be used, that there's an webcam connected to Raspberry Pi that is connected to the printer, and you can see the print from there. And when the print is finished, what do you do then? In the image here, it's an SLS machine, and the print has just finished, and you can see there's a lot of excess powder. For example, that case, you have to remove all the excess powder with a vacuum, clean it up. With an FDM printer, cool down the bed and the nozzle, or cool down the printing chamber, for example, for printing with different materials. And removing the material after that and storing it, and cleaning the printer again. The cleaning process, for example, an SLS machine is very important. So, cleaning for SLA, you wipe down the build platform from the excess material, and in FDM, you check the nozzle and the bed if there's any excess material left, so it doesn't disrupt the next print that will be started. So after that, we check the finished object. Was it successful? How are the measurements? Are any transformations in the object? In the image you see here, it wasn't successful. It had a layer skipped, and there's quite a many blobs of material on the part. And if the measurements are incorrect, they can be done. We can go back to the 3D modeling software and change a few measurements and start the print all over again. So what about post-processing? Some print technologies have post-processing procedures that have to be done. Have to be done before you can use the print. For example, in SLS was the removing of excess material. You have to suck the excess powder from the print bed, and then you have to clean out the powder print itself, like with a chamber, in a chamber. And in SLA technology, like seen in the image in the middle, you have to cure the parts. After the print is done, you have to cure it. You have to first wash it, and then you have to cure it with UV light. And in the last image, there's an image sequence about printing with an desktop metal 3D printer, which creates metal parts with extrusion technology. There's like print, then there's the debinding post-process, and then there's the sintering process after that. So there are a few technologies that require these post-processing things before the print is finished. But there's of course post-processing for these mandatory post-processing things too, or the prints that don't need any post-processing themselves, like FDM 3D prints. There's methods of coating or treating features, or mechanical treatment like sanding or chemical treatment. Coating, you can use spray paint or lacquers or epoxy coatings or stuff like that, or you can heat them in the oven to improve their features, or you can, like mentioned just before, you can sand them for the mechanical treatment, or you can use chemicals to smooth down the surfaces to create the part so that the parts look good. So, usage and iterations. Check the suitability. Does the print fit its need? Check the measurements, check the functionality. Is it durable enough? And get feedback, suggestions for that print. And if, for example, on feedback, there's things to improve, go back to the 3D modeling, make the changes, and print again. and check for the durability. If it snaps when you try to bend it, like you will have to bend it in its use case, and if it snaps, then you know that it's not durable enough. You have to increase the wall thickness or the infill, or go even to the 3D modeling software and make it more thick. Or check the material. Does the material suit the purpose? And do the measurements hold? Are they good enough so that the part fits its place? And of course, iterations come from that. Making the changes causes iterations. Changing sizes, improving functionality, or adjusting the tolerances, or making them unique. In the left image there, that's a handle for a bow. There was like 8 to 10 different iterations before the fit was perfect to the bow itself. And on the right, for the bottle that was printed, changing the size or the shape, which affects the results of the physics lab test. Again, changing them in the 3D modeling software or in the slicer affects the results that they get in their physics laboratory tests. So that was pretty much it for the 3D printing process. See you in the next video.